Hello everyone, welcome again. Sumit this side from Trendy Tech. And as you know, SQL is playing a very important role these days. If you are looking for data analyst, data engineer, big data developer, or data scientist, whatever role it is, the role of SQL is very important. And I have promised that I'll come up with a session on order of execution in SQL. So I have come up with a session now. And in this, I'll talk about when you write a SQL query, writing style is different, but execution style is different. So I will talk about the execution style and we will be seeing the explain plan of the query. Also, we will talk a little bit about indexes. So basically, this is to talk more about internals of SQL, and this cannot be done in one session, honestly. So I will have series of sessions where I will try to cover these concepts in extreme depth. So this would be the first session in internals of SQL. Okay, so let's have a small table orders, right? So we have two tables, orders and customers. These are the two tables which I already have. I will show you. I have this orders table. Let me see how many records are there. Select count star from orders. 6,800, 68,883. These are the number of records in orders table. I'll again do a start so that I show you what columns I have. I have order ID, order date, customer ID, and order status. Right? So basically, one customer would have more than one record here because if you are purchasing something from Amazon, it's not that you will only purchase once. You can do multiple or you can place multiple orders. So that's where one customer can have multiple records in the orders table. And this has just four columns. Okay. Just to let you know, order ID is the primary key. And I will show you that. So if I see here, where is it? Orders, indexes, I have primary key, right? I have primary key orders, right? And let me show you the other table, which is customers. And it has more columns. And you can see here we have customer ID, customer first name, last name, username, password, address, city, state, and pin code. Now, in our orders table also we have customer ID. In our customers table also we have customer ID. But in customers table, it is the primary key. So in orders table, what is the primary key? Order ID. And in customers table, what is the primary key? Customer ID. Now, what is the common column in both the tables? It is customer ID. Customer ID is the common column in both the tables. Right? This is how we have. I hope you are little clear about what data we have and how we have it. Okay. Now let's start looking into some details that how exactly to check the stuff. So basically, I'll show you here. Let's say I run the query select select order ID, comma customer ID from orders where order ID equal to 5. Right? I am running this query. I want two columns, right, from orders table where order ID equal to 5. Let me try to run this query. Fine, nothing so special about it. But let me see the plan for it. Explain plan. Now you can see here when I hover on it, it says clustered index seek, right? Clustered index seek. And you can see estimated number of rows to be read is just 1. That means looks like it's a very fast operation. Something has happened very good that it does not have to read so much of data for this, right? On what object this operation is performed, which is object means the table name here. We have the operation performed on orders table, and output list is we are retrieving order ID and customer ID. These two columns, if you can check. And seek predicate, that means seeking means fetching a record, right? So seek predicate is nothing but we are seeking something on order ID. So now I will tell you what do we mean by clustered index seek. So there are two things, seek and scan. I'll show scan also soon, but there are two things, seek and scan. Seek is generally quite faster than scan, and scan is slower generally. But I mean, you cannot take it that okay, always that's the case, but 99% that would be the case. Now, what is a seek and what is a scan? Seeking means that kind of you are quickly able to get one record. That is seek. Scan means you have to go through the entire data in order to retrieve it. For example, if let's say I have numbers from 1 to, or let's say I have some numbers 1 7, okay, so 1 7 4, right? I'm trying to explain you, I mean, in a way that you can understand. Let's say we have some numbers like this, randomly distributed, right? 3, like this. How many numbers are there? 4 5 6 7 8. Okay, these are 8 numbers. If I have to search 10 in this, is there a way to do it quickly? Probably not, because I have to search first this, then this, then this, and then finally I will come here. That means if there are n elements, then we have to search n elements in the worst case. Worst case. Like complexity is kind of order of n, right? That means if you have 1 lakh elements, you might have to end up scanning 1 lakh elements in order to search for something. But let's say if this is sorted, if this would have been sorted, let's say if it is something like 1 2 3 4 5, or 1 2 3 4 5 is not there, okay, 7, right? And then we have 8 9 and 10. If this would have been sorted, then in this we could have applied a binary search, and it would have been much quicker, right? So basically if I have to search now, I could, I mean, quickly search for 9, because first I can come to middle, and then again every time I can remove half of it, right? That means if my elements are sorted, the searching becomes faster, and it would be much quicker. So that's what I wanted to tell, that in a sorted thing, it's easy to find a record compared to a unsorted thing, right? Now, what happens is whenever you create a primary key, for example, on order ID, we have created a primary key. We have created, let me see if recording is going on or not. Okay, yeah, it's fine. So consider that we are having primary key on order ID. That means by default, a, a index will be created, a clustered index. So it will be, I mean, if you see, it will say clustered unique index. I'll show you again. So if I go to tables and I go to orders, where is this orders? Orders, and I go to index, it says unique clustered index, right? That is automatically created when we create a primary key. What is there? Unique clustered. Forget about unique for now, does not matter so much. right? Unique means that there won't be any duplicates, as simple as that. So that's not the matter of talking right now. What we want to talk about is what is clustered index. And the other kind of index is, yeah. So what we want to talk about, what is clustered index, and the other is non-clustered, right? So let's first talk about what is a clustered index. Clustered index is the one, for example, if I am having a orders table, orders table, and if I am, let's say, entering first record with row ID 5, there will be many other columns. So let's say order ID equal to 5. I am entering now, and there will be, let's say, another 5 or 6 or 3 columns, right? We have 3 more columns. That's fine. So totally 4 columns. Order ID is 5, right? Then this record will be inserted in the table. When another record with order ID 4 comes, it will be inserted before this, right? So ID equal to 4 will come before, right? And then when ID equal to 6 comes, it will come after this. That means it will make sure that the records are physically ordered, right? So that's where whenever a new record comes, it will try to little bit shuffle the records to make sure the physical ordering of data is maintained, right? I hope this is clear. So basically in this orders table, whenever a new record comes, it will make sure the records are sorted based on the order ID. So it will make sure records are physically ordered. So clustered means records will be physically ordered in the actual table. In the actual table. So basically at storage level, we are making sure things are stored in a proper way, neat way, in an ordered way, right? So that if you really want to search for something like select star from orders where order ID equal to something, it really do not have to scan so many records. It has to scan a lot less because it is indexed on that. And when we say index, it is sorted in ascending order and it can quickly search for something without wasting much time, right? Now talking about, let's say, when I hover, what does it say? Just a second, I'll run it again and I will say explain. So sometimes the hoover does not work. I mean, I do not know why in my system specific issue can be, right? Yeah. So now you can see it says clustered index seek, right? Seek means since it is quickly able to search, it will say it as seek. Now same query, if I search it based on customer id, what do you think what will happen? Customer ID is not a primary key, nor we have created any index on it. So what will happen now? So you can see if I say the explain plan and I hover, it says clustered index scan, right? You can say it says clustered index scan. What does that mean? That means it's not quickly able to retrieve, it has to scan all records. And you say estimated number of rows to be read is 68,883. Why is this change? Because the data is ordered based on order ID, not on customer ID. So how will it quickly search for customer ID? There is no way. It has to really read all the records from beginning till the end. In the worst case, it has to read all records and then only it will be able to tell you, right? So if we do some searching like where clause on your indexed columns, it is faster, it will be like a seek. And when we do on non-indexed thing, it will be like a scan, right? So this is on a very general note I am talking about, right? That's how it works. I hope this is clear. Now As I said, there are two kind of index: clustered index versus non-clustered index. So clustered index versus non-clustered index. What is this clustered index and what is this non-clustered? Clustered, you know by this time. That clustered means in the actual table, like orders table, we are making sure that the data is sorted based on the index, right? So, for example, let me open this, right? And I will try to show you. For example, let's consider we have an orders table, right? So let's say this is table orders, and in this, let's say the first column is the order ID, which is the primary key. Then definitely the rows will be sorted in this order: 1, 2, 3, 4, 5, 6, 7, and let's say this is the orders table, right? So this is nothing but a clustered index where in the actual table the data is stored properly. Now let's say there is this orders table, right? Now first column is, let's say, order ID. Second is, let's say, some date. Third is, let's say, some other column. And the fourth is customer ID, right? Now, what I am trying to say here, what we can even do, let's say, if we want to search something on customer ID, then you can understand clustered index can be only on one column, right? Clustered index can be on one column. It's not that you can sort it based on order ID also, and differently you can sort it on customer ID also in the same table. No, right? You can have a composite thing, but that's different. What I'm trying to say, let's say you have orders table, you can definitely create a clustered index on composite thing like order ID, comma customer ID. But what that means is, first it will sort it based on this, and then if there is any ties, it will sort based on this, right? If there is any clash, that means we are getting 555, and then for those things, it will sort based on customer ID. That's a different thing. It's called a composite clustered index. So whatever I'm saying is composite clustered index. But what I'm trying to say, what is not possible is that you have a clustered index on order ID column, and then you again have a clustered index on customer ID column separately, because that's not possible. You can have just one physical way of ordering in the same table. You're not creating two copies as such, right? So only one clustered index is possible. That's what I'm trying to convey, right? Now, talking about non-clustered index. What is this non-clustered index? We need to understand that. So I will go here. Now, let's say you are feeling that sometimes you really have to search a lot on customer ID. If in this table, whatever we have right now, we are seeing on screen, we search on customer ID, it will involve a full scan, right? It will have to search a lot of things. Then in that case, what you can do is you can create a non-clustered index on top of it. What is non-clustered index? What it will do is, basically it will have a separate index created. That means what it will do is it will have a separate structure in memory, in storage basically, right? So it will have, let's say, customer ID 102, customer ID 105, 107, 109. That means it will arrange the customer IDs in ascending order. It will sort the customer IDs, and it will have a row number or the address of that row, right? Address. That means, let's say I am running a query, select star from orders where customer ID equal to 107. Then it will see it has a non-clustered index which is there for customer ID. So it will come here, right, to this lookup kind of, and then it will see that, let's say we are searching for customer ID 105. It will be quickly able to come here because it's sorted in this. And it will be having the address, right? And this address will tell you that where exactly we need to retrieve it from the main table. Let's say this address might point to this record, for example, right? It will quickly tell, okay, look at this address in the actual orders table. So basically, it's a two-step process. First, we get the address from this index that is built, a separate index, right? And then we retrieve the record from that address. So definitely there is little bit of overhead involved because there are two lookups required. One is for the index, second is for the actual table. I hope this is clear. So this is called as non-clustered index, right? And you can have any number of non-clustered index. For example, we have on customer ID, we could have on date, any number of things. But only one clustered index is possible. I hope this would have made some sense, right? So with this, we have understood what is a clustered index versus non-clustered. I'll repeat it again. Clustered index can be only one in a table. If we are creating a primary key, then also clustered index is created. If there is no primary key, then also we can create a clustered index, but only on one column, right? However, we can have composite clustered index. That means together it's creating. So together the ordering is taken care. Now, non-clustered index can be on any number of columns, right? Need not be only on one, but it creates a separate structure. So the overhead is that for non-clustered index, it will require little extra storage because it has to keep the data. And moreover, in terms of reading also little overhead is there because first it has to check from the index, which is external index that is built, and it has to get the row address, and then it refers to that row address in the actual table, right? So that's how it works. Now, what is scan and seek? Scan is when we are not retrieving the rows based on any index, right? Then it will go for a scan because it has to go row by row. Seek is when it can quickly find it out. Okay. So now when I come here, you can see it says clustered index scan. That means it's not referring to any secondary indexes or somewhere else. It's referring to the actual table. The moment you see clustered means the actual table. Index scan. That means somehow it's not able to retrieve it faster. It has to go row by row. I hope this is clear because there is no an index on customer ID. But the moment I say order ID, then things change a lot. It will go for, I will show you what it will do is it will go for clustered index seek and it will be much, much faster. I believe this would have given you a good clarity on what I am trying to convey. So let's proceed in our discussion. Now, you have understood scan versus seek, clustered index versus non-clustered index. Now, let me try writing a query. What query I will write? I'll say select. First, I will write in a notepad, then I'll copy so that you have a good view about it. Huh. I will say select. Let's say city, comma count star, city, comma count star as total from orders, join customers. Do not worry, I'll explain you this query on orders dot customer ID equal to customers dot customer ID. Okay. Now I am trying to join these two tables based on customer column because it's a common column. That's fine. Where I'm having a filter condition also. Order status, let's say not equal to pending. There are many status types actually. I am saying I do not want to have pending payment status. Pending payment. Okay. and I want to group all the results by group by city, right? I want to check for each city how many total orders were placed. Group by city having count star greater than 10, right? Order by total DESC. I am running a query, this one. I'll explain you now. What I'm trying to say, I want to get for each city what's the total number of orders, right? For each city, what is the total number of orders? Let me run this query first and then show you so that you can understand it better. Huh. So you can see this CAG was 19,871 orders, but which follows what all conditions? That okay, what we are trying to say, order status was not pending, right? Pending payment, and moreover, we are trying to only get all the cities where the number of orders are greater than 10, right? So if you see, you will be able to find it greater than 10. So you can check this out. Select city, comma, count star as total. We are giving this alias from orders, join customers. These are the two tables. We are joining it based on the customer ID, which is the common column among all, where order status not equal to pending payment, right? So order status is in which table? This is in our orders table, right? Group by city, right? We are grouping it based on city having count star greater than 10. So all the cities where total orders were more than 10, we are finding it out. I hope this is clear. And then we are ascending it, we are ordering it based on descending order. That means whatever city has maximum number of orders placed will come first and the others will come later. Right? So that's how we have ordered this one. Okay, now, so what we will try doing is we will want to see the explain plan for this. Okay, syntax error near star. Just a second. Okay, sorry. I have to select and explain. I'm showing you the explain plan. Unfortunately, somehow this hover feature sometimes does not work. It's a UI issue at my end. Might not be you won't be facing it, I believe, but I would have a different way to show you that. Do not worry. Yeah. So now, if you see here, the same query, let me take and run it in a different terminal. I have set show plan all on. Do not worry about what is that. Nothing to worry. I will run this here. Right now, do not worry what I am trying to do. I will run this. And the same thing is in the text form here, actually. Since I was not able to hover on it, right? Hovering does not was not giving results. So I am having these things in text format so that I can show. So the very first thing that happens is, or how you have to read this plan is, you have to read it from right to left and top to bottom. That means you read it from right side to the left side and top to bottom. So I will say read the plan right to left and from top to bottom. Now you can see first thing that's happening is we are reading the data from the tables. Now whether it's a scan or seek, let's see. I'll come here and you can see this clustered index scan. It is a scan because customer ID, we are trying to get the data from both the tables. So you can see here, if I expand this, you can see clustered index scan retail db dot orders. So this is the orders table, and it is getting the orders. Even the where class clause it is putting here pending payment. If you see here, this this clause order status not equal to pending, it is moving it more towards the storage so that we do not get extra records. We want to apply filter as soon as possible, right? Since it is able to do that, it has moved it initially only so that we only get the records that we want. Otherwise, why to have unnecessary records for further processing, right? So it tries to move the filter down, right? It is also called as predicate push down. That means filters are applied as soon as possible, whenever possible, because it should not give you wrong output ideally, right? If it feels that okay, it won't give you the wrong output, and it can move filters down so that we cut unnecessary data as early as possible, it will try doing that. And that's what you can see here. So whenever it's getting the data from orders table, it is applying this filter condition also, right? And you can see this arguments, same thing will be mentioned here. You can check this out. And output list, what all columns it will give you finally, it will only give you the customer id. From this only it will give what customer id, because other columns are not required from this table. You can check this out. So from your orders table, it is only giving you customer id, nothing else. I hope this is clear. That's where output columns list show you. Because why should it take other columns into consideration when it's not required? So it is eliminating unnecessary data in terms of the filter or in terms of the projection initially only. Fine. So now talking about the second scan that's happening, that is on customers table. So you can check this customers, and now uh, here what it's doing is it is again getting what all columns customer id, because that's required for join. So from both tables customer id is required, but what other column is required from this table? City, right? So only two columns it is taking, and remaining it won't take, I mean, forward. So kind of it has applied filter on orders table and just getting customer id from there. It has, I mean, it is just taking customer id and city from the customers table. So kind of eliminated a lot of data in the very initial stages, very starting, right? So this is how it is. Now, after this, what happens? After this, what happens? This do a join. Now, do not worry about hash match join or merge join. I'll talk or I'll cover in a separate video what are the different kinds of joins. It's not about inner join, left outer. I'm not talking about that. But how exactly server or SQL server is doing it internally, right? Hash join or merge join or it is a nested loop join, I'll talk about in a separate section. Do not worry. So now, once we have these two tables, it has read these two tables, it is doing a join on it. So what is the, I mean, first it do uh, from, right? And then it do join, right? So it reads two tables. So this is the order from and join. After that, what it's doing, and this join also I will show a little bit here. So if you see here, join, what condition is there? Customer ID equal to customer ID, right? In both the tables, and it's a inner join, and you can check the argument if required, and you can see the output list is city, because city is the only thing we want to take forward now, right? So that's great. Now, what is the next thing that happened? The next thing that it's doing is it is doing a grouping aggregate. We have group by, right? So I'll write here after join, it's doing group by. Now, remember, along with your from whenever it's reading the data, it has done the where clause also, but not in all every case it can be done here actually. Sometimes it has to do after join. I'll tell you a scenario. For example, let's say you are joining two tables, and after that you are doing a filter based on, let's say you are concatenating one column from orders and another column from customers, and then based on that you are doing some filter. Then before joining, how does it know that after concatenating these two columns from two different tables, how the data looks? So in that case, it has to do that after join only, right? So there can be cases where your filter happens after join, but whenever it can do before join, it will be more inclined towards doing that. I hope this is clear. So if you actually see in articles and all, it says from join and then after that where. But where can be moved at the very initial stage whenever it is possible for the system to do. After that, we have group by, which we have seen in our case also, it's the same case. Fine. After this group by, we have what? So we have join, we have group by. So group by I'll show you in this. So you see this aggregate, and if I go here, you can see since we are doing count star, that is the expression it will have to calculate, right? It will have to calculate count star. And what are the two columns now? City, comma, expression 1007. 1007 is nothing but count star, because these are the two columns we are talking about in group by, isn't it? So you can see this, right? And you can check this out at your end also. Aggregate is done, and you can see in this plan the cost is there: 10%, 33%, 36%. I will have a separate session where I talk about it, but just to let you know, when you are doing performance tuning, you are more inclined to check the operators where cost is high, because those are something where you have to focus on so that you reduce the cost. If it is 0% and all, then it's something where you should not be worried, because it's not taking much of the time or resources, right? For example, if optimizing this one, I would focus more on, let's say, this hash mesh inner join, this is 36%, or to some extent I will focus on this one, right, where the cost is more. But right now in this session, my intent is not to tell you how to do performance tuning in this query. I'm just telling you the flow, right, how exactly the SQL query is executed logically. So you we have done this group by. After that, this is basically what we are trying to do is we are casting it. So it's a very simple operation where we are casting that count star to int. If you go here, you can check. So we do not have to really worry too much about it. Compute scalar, and this convert implicit integer. I mean, so we are converting count star into integer. That's a very simple operation. That's it. It's performing, right? And now whatever new expression is there, it's giving the name as 1004. You can check, right? And what are the output columns now? You can check this: city, comma, expression 1004. That means integer casting of count star, right? Earlier it was count star, but now it's just having a implicit conversion of it. Okay. Now what is the next thing that is there? Filter. Filter in the sense having clause. So if I go here, and in this, I'll show you filter where, what is this expression 1004? Count star greater than 10. Where do we have this condition? Count star greater than 10. If you see here, count star greater than 10 is like a having clause, right? So it is trying to filter the records based on this condition. And let me move ahead. If I go forward, you can check this out, where count star greater than 10. And after that, what are the things in output list still the same. It won't change till the end now, right? So you can see if I hover, does it come? No, it's fine then, no issues. That's why I have the text mode on because of some issues at my end. Now, after this filter, what exactly is happening? So I'll write here group by having. Having is nothing but where, right? Filter. And then after that, we have sort. So I will show you this sort. So if I hover on it, it says total number of rows, right? That so total number of rows per execution 562, right? And now if I actually go there in the sort, you can see we are sorting it based on descending order of count star. You can check this out, and we are retrieving the results. So this is how it is, and after that it's like printing the results. So after that we are printing. So this is how it goes. So generally remember this point, that if you see officially, then it will look like this when you see documents from join where, but where can be clubbed with from when retrieving the data, right, or scanning the data. It can apply this where, so that it's like a predicate push down and we eliminate, data as early as possible, so that we deal with lesser data. Then we have group by, then we have having, select. Now, do not get confused with this select, because this select shows before order by, and whatever we have seen as per us, our select is here towards the end, right? Order by is this, and select is coming at the end. Remember, this select is not something like the select that we see as part of ordering in the documents. This select says that, let's say, if we have any functions in the select, it will be calculated this time, right? Whatever select we see in the diagram is like print statement, think of, and it will be always there in all the plans, right, with cost 0%. So do not worry about this select. Think that this is of no value right now, whatever you are seeing select here, right? And then we have order by. Limit I will show you, I have not talked about it right now. I hope this is clear. Now what I will try to do here is, for example, I am saying group by city having, can I say total greater than 10? Total greater than 10. Can I do that? See, I have given this alias as total, right? Count star as total. Can I do this? Let me try running this. And it says invalid column name total. Why it's doing that? In having, why it's not able to read? So you can see this. Basically, the select clause comes, that means aliases and all will be taken into consideration when coming to select here later. Right now, aliases are not into picture as of now, right? So if I have done count star, I have to refer it with count star only. I cannot use the aliases because select comes later in the list, if you see, right? So for example, in my select, I have this count star as total. Select is not evaluated as such till now. Select will be evaluated after having. So that is why aliases cannot be referred in the having clause. And that's where it was failing. So that's why I have to refer it as count star. I hope this is clear. I'm trying my best to convey it in the best way. Let's see how it goes and how much you are able to grab. And I'll be doing a series of sessions on this, because things cannot be explained in one session, honestly. It's just like an overview right now that I am giving, but super, super important, honestly. So now let us do a slight variant of this query to understand more. What I will do now is, let's say, I will say, what I will try to do, I will do one thing. I'll make a slight change in this query. I'll take this query, right? I'll take this query, and what I will do is I'll put it here. Everything is working fine, correct? Now, what I will do, I'll change this having clause. In this having, group by having count star greater than 10. Instead of count star greater than 10, what I will say, having city, having city equal to, let's say, Phoenix. It's one of the city, right? I'm doing this. I have a particular reason to show you this. Ideally, I should not be writing this in the having, but I want to demonstrate something. That as simple as that. Okay, and I'll say explain. Now you can see it first reads the data from both the tables. It is having a join and then group by. There is no having clause. There is no having clause. Then where has that gone? I mean, are we not filtering the data? We are filtering, but system is smart enough because system says that when I know that I have to just get the data for city equal to Phoenix, then while doing the reading from tables initially, why don't I just get those records? That is, it will push this filter down to the storage layer, and it says only get me those records. See how beautiful the system is. I'll show you here. Let me run this. Take here and put it here so that I can show in the text format. And now, if you see here, I will again put it down. Okay. So you can see here where city equal to Phoenix. It has pushed it at the very bottom so that we are eliminating unnecessary records as early as possible. But when we are saying we are having count star greater than 10, that it could not push to the storage layer because I mean count star greater than 10, that means first group by should execute, then only it can know that count star is what number. But in this case, there is no requirement of doing group by, then only we will get to know. No. At the starting only we know, okay, I mean we can filter based on city equal to Phoenix. Right? So sometimes you have to understand that it's not that what I mean these steps are given by documents and all. It might not follow this. On a general note, it will follow this, but sometimes it will shuffle these around or it will do differently so that you have a better plan or a optimized plan, right? System is intelligent enough, so I'm saying do not always follow this that okay it should be like this. No, not necessary. I'll show you one more example. So what I will do now, I will again take this, not this one, I'll take the previous one and make some changes. Okay, what I will do now is I will let's say what I will do, select top three. Okay, I'll now have this top three command. Select top three. This is like a limit. I want to have only three records. City count star as total from orders, join customers on orders dot this, where order status not equal to pending, group by city, right? Group by city, and let me remove the having clause, right? Group by city, order by total, right? And let's say not even this. I want to, or even this does not matter, right? I want to have this. I'm saying I want to get top three cities from where maximum orders were placed. Actually, I want that. So let me run this command, right? And run this. I will say explain. So you can see here, first it reads the data from both the tables, then it do a join, then it did a group by, right? After that, it is doing a sorting, right? So you can check this out. It's doing a sorting, uh, order by, basically order by towards the end, which is as per our this thing, that after group by only we are doing this sorting and all, so it's all fine. And after that, it is getting you the top few records, top 1%, right? So that's how it is behaving. So let me even run this query here to show you more. So initially, what it's doing, it is doing a clustered index scan on both the tables. It's doing a join, right? And let's me do see if any filters it has moved. So it has moved only for the orders table where order status not equal to pending payment. Okay, that's great, right? Then it's doing a join. Then it's doing a group by, right? Sort top three. Now all of this is fine, and this is as per what we were expecting, correct? Now what I will do is, let me again go back and tell you one more thing. If you hover on this arrow, it says that okay, this command has given 562 rows here to the sort. Now, has it done all the sorting and then selected top three? No, system is smart, and what it do is top and sort. That means it would have found the maximum and then the second maximum and third. It has actually not sorted, and that's where you can see it is top and sort. It is saying, right? It would have done a very quick sorting. It would not have sorted all the results. It would have just got the top three only, right? Top three. If there are 1,000 elements, and if I have to uh, sort all, for example, if there are 1,000 numbers, if there are 1,000 numbers, right? Different numbers, and I want to get the top three from this. There are two ways. Either I first sort all the 1,000 numbers and then get the top three. This is one way. Or you can scan all the numbers one time and select the topmost, then select or go through all the numbers and select the, I mean, second topmost, and like that. So there can be a faster way of doing without doing the actual sorting, and that is what it actually says when it says sort top and sort in the brackets, right? So you can see this. The sorting itself is giving you three elements actually. I hope this is clear. Now, so this is like optimization system has done internally. Now let us slightly again fine tune the things, change it. I will make a slight change in this query. What I will do is I will now have having clause, group by city, having count star, count star, let's say uh, greater than greater than 100. I am having this. I am running this query. Let me run and say the explain plan. Okay. Now what I am trying to say, I want to get top three, but before that I am filtering based on this criteria that okay, count start should be greater than 100. Ideally, it's a very logical query, but I want to show you certain thing here. What I am trying to say here is, if you see the order of execution, first it read both the tables, then did a join, then did a group by, then did the having clause filter basically, right? This is the having clause, and then it did the order by, right? And then it gave the records. This is very much in lines with the official thing which generally is put on documents and all, right? You can check this out. That order by Having is coming before the order by. If I run the same query here, you will understand it much better. Right, you can see here it did a full clustered index scan. Then it did the join. Do not worry about how hash join, I'll have a separate session on that. And then it did group by, right? Group by where we have count star, right? And then it did a implicit conversion into integer. Then it applied the having clause, right, where count star greater than 100. And then it sorted it based on descending order. Awesome, right? Isn't it? So now again here the sorting it's doing is optimized one where it might not be sorting. It is doing a top and sort. Very, very quick sort. So that finally after this only three results are there. It's not spending time in doing every sorting. No. Now let me make a very small change here and then you will wonder how come things have changed. Right? Let me say count star greater than 10. Count star greater than 10. Remember what we had right now is filter first and sort later. And I just changed the value of count star from 100 to 10. And let's see. I run it. And again, I explain the plan. And you can see the sort is coming first now and filter is coming later. See, the beauty of the engine is that engine knows, I mean, based on statistics, how to optimize the query. It's not that you always think that, okay, whatever is given in document, this is how it has to go. No. System can bypass this rule. System can follow a better approach. Now here you see sorting is happening first and filter is happening later. Right? Because see, I mean, system knows that in when it goes through this route, it can be faster, right? Because now it is saying if I am doing sorting anyways, filtering will become easy, right? Because I am saying that okay, I want to get records which are more than 10, right? That means kind of if we are doing filter here first, I will tell you what I'm trying to say. There were two scenarios we have seen: count star greater than 100 earlier and count star greater than 10. These are the two scenarios. Here what happened? First we have in order is we got the filter first, right? And then we got the sort. Here we are getting the sort first and filter later, right? Now it's very hard for us to determine why system has done, but system would have statistics to understand that if it do it this way, it will be faster, right? As simple as that. We do not have to think too much, but what I can think from my mind that what would have happened here is in this case, since count star greater than 100, when we do filter, kind of it will give us very less rows actually, and then sorting becomes easy on that because now this value is greater. That means it will eliminate a lot of rows and will give very less rows so that sorting becomes easy. That's why it would have followed this approach. And when we are saying count star greater than 10, that means there will be still lot of values which will come up in the results, right? And then we have to do almost sorting on all things. So system would have thought, let me do sorting first. And then anyways, when I'm doing sorting, after that, the filter can be that after a certain point, I can take all the records that will come in filter because I'm saying greater than 10, right? So once I reach to 10, after that, all the records I can take, right? So kind of we are not eliminating too many records here. So system thinks even if I do sort here, it can be beneficial first. But in the previous case, it might think that okay, since we are eliminating a lot of records, right? The result set after filter will be very small. So small number of elements have to be sorted. So let me follow this route. This can be one approach. My thought process can be different, but system knows all the statistics that what it will do so that it performs faster, right? So I'm trying to say, although we say that this is how it works, but there can be cases that this is not how it works. right? Interesting. And we will try to dig deeper. From my side, I have tried my best to convey things as per my understanding. At some places even I might have gone wrong in my understanding, right? There is no doubt, because not everything is available in terms of documentation and all. Some things we think as a human mind logically, which can be incorrect also, but that's my thought process to this problem, right? And if you have a different thought process, do mention in the comments. And if you have not subscribed to my channel, do subscribe. I'll make sure I will have this series in a way that you people enjoy it to the level best. And I will give my wholehearted effort in this series to make sure this is one of the best series available on YouTube. And I will go so deep that none of the person has gone. Right? So with this, we will wind up. But again, quick recap of what we have learned. Initially, we saw that how to see the explained plan. Right now, I'm using the Azure SQL database. Right? You can use anyone, and I am seeing the explained plan. I have shown you that we have different objects. There is a cost associated with the objects. A thick line means more data is getting transferred. And you see this plan from right to left, top to bottom. We talked about the indexes, clustered index and non-clustered index. Clustered index is the one where data is kept intact in the table, so that physical ordering of, or physical storage of data is impacted in the table. But when we talk about non-clustered index, we create a separate thing, just like the index at the start of the book, where we first check there and then go to the actual pages, right? So it's like a two-step process, which will be little bit cumbersome but still beneficial, right? So we can have only one clustered index on a table, but we can have more than one non-clustered index on a table, and indexes make our life easy. And seek is faster, scans are slower, but again, you cannot always say, just like I have shown you, that whatever we say might not be true always. Same way it goes with seek and scan also, right? For a very small table, I mean, kind of, scans can also be faster than seeks, just to let you know. Okay. Now, we talked about various scenarios and we saw various things with lot of different changes in the queries, that how exactly our plan goes, right? Sometimes we have seen sorting before having, and then sometimes we are seeing having before sorting. So it goes very differently, very, very differently. But generally, if someone asks you what is the order of execution of query, you have to tell this. But you can say that this is just a very generalized case. It can change based on the statistics the system has, and system can take a better plan in place to approach my query. So with this, let's end the session. If you have not subscribed yet, please do, and I'll make sure I'll keep on adding such interesting videos to this playlist. Thanks a lot.